How do we take the square root of a complex number? So as you know, a plus bi is in rectangular form, and this is polar form, and that will be used during this video. Now this r here, that's this r, that's actually the distance from the point to the origin. In this case it's 1, but you can easily calculate it by just taking the square root of a squared plus b squared. That's just the Pythagorean theorem, because you can see in the picture this one squared plus this one squared is this one squared. Now you have to take the square root of that. This theta is just the angle. It's this angle. And using basic trigonometry we can see it's the inverse tangent of b divided by a. And that's that. So that's the polar form. I'll just be using r and theta, because writing down that will take a long time. Using the polar form it's a lot easier, because this is multiplying, so we can just do the square root of r times the square root of e to the I theta. Now this square root will just keep it that way. Now this, we can get this square root sign, we can actually do e to the I theta, and that to the power of 1/2, because that's the square root. Now we can multiply the exponents, so that's square root of r times e to the I theta divided by 2. Now that's the new polar form, but we want this I to be alone, so that's square root of r times e to the I times theta over 2. Now we want this in rectangular form again, so we'll use Euler's formula. So the square root of r, and we have to multiply it by this, so that's the cosine of the angle, so that's theta divided by 2, plus I sine of theta over 2. Now we work that out, and we get the square root of r cosine theta divided by 2 plus I square root of r sine of theta over 2. So let's calculate the square root of I. Now first we need to calculate r, the radius. So a is 0 because we have no real part, and b is 1. So that's the square root of a squared plus b squared. So that's 0 plus 1. That's the square root of 1, and that's 1. The angle is a little weird because a is 0, so we do inverse tangent of 1 divided by 0. But you can't divide by 0, so we'll just take the limit of it. So that's as x approaches 0 of inverse tangent of 1 divided by x. Now, as this approaches 0, this number inside will approach infinity. So that is the limit as, let's choose h, approaches infinity of the inverse tangent of h. And we know that that is, in radians, it's pi divided by 2. So this is the polar form of I. And now we're going to take the square root of it. So we say the square root of I is the square root of e to the I pi over 2. So the square root of I is e to the I pi over 4. Now, using Euler's formula, we can say that this is cosine of pi over 4 plus I sine pi over 4. Now, the reason we don't have r is because the r we computed is 1 and the square root of 1 is still just 1, so it won't do anything. Now this, we know that this is the square root of 1/2, and again this is also the square root of 1/2, so I times the square root of 1/2, and that's actually equal to 1/2 the square root of 2 plus 1/2 I square root of 2. Now here are my 4 challenges. This one, 1 plus the square root of 1 plus I. This one, 2 plus the square root of 2 plus 2i. Now you can actually calculate this one from this one. And then this one is the square root of 1 minus I. And this one is a weird one. It's the square root of pi plus 4i square root of 2. And that's weird because you'll probably never see that one.